Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to continue with rational expressions, but we're going to learn how to simplify complex rational expressions. Sometimes these are known as complex fractions. And before we can really work with them, you have to recognize what they are. And a complex fraction is a rational expression that has at least one fraction in its numerator and or denominator. So you need at least one fraction in the numerator and or the denominator. What does that mean? Well, when you look at the examples that I have right here, and you look at this first one, you got 1 over x plus 1 over y. That is a rational expression. That's easy. Divided by 1 over xy. That's another rational expression. So when you have a rational expression divided by a rational expression, you have a complex fraction or a complex rational expression. So this would be your numerator and this would be your denominator. We're going to show you how to work with that in a second, but I need you to understand how to recognize it. So here, I've got this fraction right here divided by this fraction. That meets the criteria for a complex rational expression or a complex fraction. This is your numerator. This is your denominator. You got something really ugly like this. That's okay. This is a rational expression divided by a rational expression. So this would be your numerator and this would be your denominator. So anytime you have, once again, a rational expression divided by a rational expression, it's a complex fraction. Now, we recognize them, nice and easy. How do we solve them? Well, there are two methods for simplifying complex fractions. Some of you are going to like one method. Some of you are going to like the second method. Some of you are going to like both, but you're going to realize that sometimes it's better to use one method or the other, and that's fine. Me, I like one method in particular. I stick to it pretty much always, but I've done a lot of these problems, so I know how to work with it quickly. I need you guys to learn both methods, choose the one you really love, and use it. If you see while we go through all these examples, hey, wait a second. I think method 1 would have been easier for this one. Hey, I think method 2 would have been easier for this one. You can pick and choose what to do. That's why I'm going to teach you both. So method 1, guys, is going to be pretty much the simplest in concept, okay? Step 1 is simplify both the numerator and denominator individually. What does that mean? That means add the numerator. By adding the numerator, you add the rational expression in the numerator. Then you add or subtract or simplify the denominator of the complex fraction. Then you change, flip it. So the LCD for this numerator would be what? xy. So what do I have to multiply here to get xy in the denominator? A y. What do I need to multiply here? So I'm left with x plus y, excuse me, over xy divided by, I'm lucky here, I've got nothing to add, so I got 1 over xy. So that's my first step, simplify both the numerator and denominator. Number 2, divide. Remember that when we're dividing fractions, it's stay, change, flip. Stay, change, flip. So stay, change, flip it. X plus y over xy, that stays. Change, flip. The xy's cancel because they're both perfect monomials. And I'm left with an x plus y. And that's my last step, simplify. Does that make sense? Okay, so hopefully that makes sense, guys. Now, let's do method 2. Method 2 is a little bit different. For some of these, it's going to be way easier. For some of them, you may think it's more difficult. It really depends on you guys. But let's go through the procedures, and you guys decide what you like for you. Number 1, find the LCD of all the denominators. So remember that this numerator has this x and y as a denominator. This denominator of the complex fraction has this xy as a denominator. So I like to call this the grand LCD. That's just a name I made up to remind myself I'm looking for the LCD of everything. So if I look for the LCD of every single denominator here, it's XY. Step 2, distribute the LCD to all of the numerators. So I am literally going to take this XY and multiply it here to here and to here. What's happening here, guys, when I use method 2, the beauty of it is that I eliminate the denominator. I'm getting rid of the denominator. It's gone, okay? For example, xy times 1 over x leaves you with y. xy times 1 over y leaves you with x. Over xy divided by xy, or xy times 1 over xy leaves you with 1. And that equals x plus y. A lot less work in this particular situation. I cannot guarantee you that it's always going to be less work using method 2. 95% of the time, it will be less work. That's why you guys will have to pick and choose what you want to use, how you want to use it. Okay? And of course, sorry, step 3 is just simplify, but this one was pretty easy. It was already simplified. So let's continue. Let's just do a bunch of work. I'm going to do all of these in both methods. That way you see both methods. That way you see the plus sides of both methods and the minus sides of both methods. You can see the pitfalls of both, okay? So for this first guy, actually, let me do it this way so life is easier for me. Let's clone this. I'm going to shrink this here. I'm going to shrink that there. Okay, so method 1. Okay, we'll do this in red. Method 1. Method 1, I'm going to just add the rational expression in the numerator, add or subtract the rational expression in the denominator. I'm going to divide those sums or differences and then simplify. So my LCD for the numerator here is xy. So what I need to multiply here to get an xy? A y. What do I need to multiply here? So I multiply by an x. So that gives me x squared plus y over xy. Does everyone see that? Divided by, what's the LCD of this guy down here? LCD here is y. So I don't have to multiply anything to this 1 over y. What do I need to multiply here? A y. So I get y plus 1 over y. Does everyone see that? Yes, sir.
So for the first method, you have to find 2 LCDs.
Exactly. For the first method, you're literally finding 2 different LCDs. The LCD for the numerator, because you got to add that rational expression in the numerator. Then the LCD for the denominator, because you got to add that rational expression in the denominator. Exactly right, my brother. That's why it is more work. Yeah. It is more work. But who cares? If you feel good about this, guys, hopefully you know me by now. I'm not here to tell you how to do it if there's several ways to do it. I'll teach you all the possible ways. You choose. Some things is just, hey, this is the way it is. I'm sorry, guys. But this is not one of those. When I teach you 2 different methods or 3 or whatever, you choose the one that works for you. Thank you, my brother. So now stay, change, flip. So stay, change, flip. So here, my y and my y can go bye-bye, and I'm left with x squared plus y over x times y plus 1. I'm done. Temptations. Temptations. Oh, let's get rid of this x and one of those. No. You cannot do that. Oh, but I can get rid of this y and this y, right? No, you cannot do that. You cannot simplify individual pieces of polynomials. Now, let's see what happens here, this guy with method 2. Method 2, I'm going to find the grand LCD. So what's my grand LCD here? XY. I'm going to literally multiply XY to every single fraction that I have here. So what's XY times 1 over X? Y. What's xy times x over y? X squared. What's xy times 1 over y? What's xy times 1? Factor this out. So I've got y plus x squared over x times y plus 1. Do you see that they are the same exact answer? Again, I'm no sarcasm, but I don't care which method you use. Learn one at least and become a master at it. Or learn both, and then you can pick and choose when to use what. Okay? May I continue? Okay, this one's pretty simple. This already has, it's just a variable. It's just a term up there. There's no rational expression. So all I got to do is add this one. What's the LCD down here? XY. What do I need to multiply here? A Y. And here? An X. So this is X over X plus Y over XY. Stay, change, flip. Stay, change, flip. This is X squared Y over X plus Y. What are the temptations here? Oh, let's get rid of one of the X's. Let's get rid of the Y. No, no, and no. You cannot do that unless there was a monomial being multiplied to that X plus Y. Does that make sense? All right. If I wanted method 2, go ahead and do this. If I wanted method 2, what's my grand LCD? So I am literally going to multiply xy to every single term. So this will be x squared y over, what's xy times 1 over x? Sorry, it's y. What's xy times 1 over y? Bam. They're both the same, aren't they? Does that make sense, brothers?
Yes, sir.
Okay, now let's get to another one. All right, boys. Now, let us continue. So, let's do this method 1, okay? Method 1, what's the LCD here? LCD is 5x. What do I need to multiply here? On x. And here, a 5. So I got x plus 5 over 5x over, oh, that's it. This is an easy one. Stay, change, flip. Thank you, Papa. Good job. So x plus 5 over 5x times 2 over x plus 5. Cancel. 2 over 5x. Moro, why could you cancel those? Because that's a binomial, x plus 5. That's the same binomial, x plus 5. I can cancel out monomials, and I can cancel out binomials as long as they are perfect. You feel me? Now, method 2. In this case, method 2 would not be the way to go, in my opinion. So you got 1 over, well, why am I doing that? Let's save time. You're here to learn, not to watch me write. Okay. What's the grand LCD? 10x. Good job, guys. So I multiply 10x to every single thing. So 10x divided by, times 1/5 is 2x. 10x times 1 over x. So this here will just be 2 times x plus 5. Always factor. Now, what's 10x times x plus 5 over 2? Hold on, no, don't get crazy. I'm proud of you, but look, make your life easy. First realize, remember, we're doing some of this in our head because it's easy. Sometimes you may want to write it out. I've done a lot of these, guys, so it's not fair for me to anticipate or expect you to do it in your head. There's no shame in showing work at all. Remember, this 2 goes into 10 5 times. So I'm really distributing a 5x. So this would be 5x squared plus 25x. Factor out now a 5x, and I'm left with x plus 5. Fuagada. My answer is 2 over 5x, which is the same as this guy. Does that make sense, my brothers? Promise? Okay. This guy, method 1. What's the LCD of the numerator?
X times X plus 1.
X times x plus 1. Beautiful. What do I need to multiply here?
X plus 1.
I got to multiply an x plus 1. What do I need to multiply here? An x. Okay. Please, guys, be careful. X plus 1 times x minus 2 is not x squared minus 2. You have to FOIL. X times x is x squared. Actually, wait. I want to have space. X times x is x squared. X times negative 2 is negative 2x plus x, so that's negative x. 1 times negative 2 is negative 2 plus 2x. So this is x squared plus x minus 2. But wait a second. That's factorable. That can be factored into x plus 2 times x minus 1 over x times x plus 1. All I did here, guys, was this numerator. Does that make sense so far? Okay. What's my LCD for this guy? X minus 1 times x plus 1. What do I need to multiply here? On x plus 1. And here? On x minus 1. Now, so this is over 3x plus 3. Please remember there's a negative, so that negative 1 has to distribute. Minus x plus 1 over x plus 1, x minus 1. Let's go ahead and clean this top up. 3x minus x is 2x plus 4, right? So let's actually clean that up. So what was it? 2x plus 4? Plus 4, which actually factors out to be 2x plus 2 over x plus 1, x minus 1. Stay, change, flip. So when I stay, change, flip it, I've got x plus 2 times x minus 1 over x times x plus 1 times, flip, x plus 1, x minus 1 over 2x plus 2. Have a good day, have a good day. See you later. Bye-bye. So I'm left with x minus 1 squared over 2x. Does that make sense? It's long. It's a tough one. Now, let's see how that works with method 2. Method 2, I'm looking for the grand LCD. So what's my grand LCD here, guys? Yeah, this is a tough one. This is x plus 1, x minus 1. So I am literally going to multiply that to here, 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 and here. So when I multiply x times x plus 1 times x minus 1 to x minus 2 over x, the x's will cancel, correct? So I'm left with x minus 2 times x squared minus 1. Why did you do that, Moro? Well, it's a difference of squares. Beautiful job. Thank you. X plus 1 times x minus 1, that's x squared minus x plus x minus 1. Middle terms will always cancel in a difference of squares. Plus, when I multiply my grand LCD to this guy, the x plus 1's cancel, right? So I'm left with 2x times x minus 1. Does everyone see that? Yes, sir, my brother. Thank you. That is, I've never told you I'd rather do one method or the other. Never.
Before we distribute the grand LCD, you want us to cancel and do.
No, I did not cancel. I did not cancel. I am distributing. While I distributed, I cancel. When I multiply this to this guy, don't the x's cancel here?
Yeah. Do you want us to combine the x plus 1 and x plus 1?
Yes, yes. I'm not done yet. I'm just going step by step. Thank you, Papa, for caring. So now let's clean this up. X times x squared is x cubed minus x minus 2x squared plus 2x squared minus 2x. So that's going to give me a numerator of x cubed, these guys cancel, minus, what happened? Yes, plus the 2. Okay, thank you, this guy. Thank you. I was going to say, that's weird. Minus 3x plus 2 over. Now, I got to multiply the grand LCD to everything down here. So when I multiply to everything down here, the x minus 1 cancels. I'm left with 3x times x plus 1. When I multiply it here, I'm left with minus, the x plus 1 cancels. I'm left with minus x times x minus 1. You with me? So this is 3x squared plus 3x minus x squared plus 1. So that leaves me with 2x squared plus 2x. From here, I have 4x. Thank you, my brother. From here, I have x cubed minus 3x plus 2 over, take out a 2x, and I've got x plus 2. Now, hold on, Morrow. You did something wrong. These two do not look the same. No, they do not. Yes, sir. You can't factor it out, but you can divide. In this particular case, first of all, let me make this clear. If this was your answer and you put this on the test, you get a big fat yes. That's your answer. I just want to prove to you guys that both of these answers are equal. That's all I'm doing here. What I'm about to do here is just to show you that they're both equal. Both of these answers would have worked. On my answer key, I'm going to have to do it method 1 and method 2. That's just the way it goes. Because some of you are going to do a method 1, some of you are going to do a method 2. 98% of the time, they both come out to the exact answer and they look the same. Sometimes they are the exact answer, but they don't look the same. So I have to be responsible for making sure that I do the key correctly. However, let me go back to proving that this equals what was in green. If I take these guys right here and divide it using synthetic division, okay, this is a negative 2 is my root from this guy. Now I put my coefficients. 1 for the x cubed, 0 for the x squared, negative 3 for the x, and 2. Remember when we learned this, that I said this will come back to haunt you or help you? Here it is. So drop the 1. Negative 2 times 1 is negative 2. That's 0 minus 2 is negative 2. Negative 2 times negative 2 is 4. That's 1. Negative 2 times 1 is negative 2. It goes in perfectly. So what am I left with? I'm left with x squared minus 2x plus 1. So what did I just do there? I'm left with an x squared minus 2x plus 1 in the numerator over a 2x. Because I already divided this into that, right? So that's gone. You feel me? And then if I factor this numerator, guess what? That's x minus 1 squared over 2x. And now, can you see how they're both equal? This guy does equal that guy. Again, do you have to do that? No. Why did you do it then, Morrow? To prove to you. Both methods will always work. This answer was identical. This answer right here was identical to the first one, just not simplified. Sir, my brother.
How come you didn't do the division 2x?
Because the 2x is a monomial, and that's separate. I divided the x plus 2 from this to see if I could simplify it, which I did, to x squared minus 2x plus 1. And now I'm done. Now I'm done. Again, guys, you don't have to do this step. I just wanted to prove to you that both steps will render you the same answer. This guy and this guy are the same. You feel me? Let's continue, my brothers. Thank you. You're the best. Okay, next. Okay, now, what method do you think would work best here? I think method 2 would be way easier here. Okay, what's the grand LCD here? Yeah, y cubed. So multiply every single term here by y cubed. So what's y cubed times 2 over y? 2y squared, thank you, my brother. What's y cubed times 8 over y cubed? Negative 8. So from here I factor out a 2, and I've got y squared minus 4, which gives me 2 times y plus 2, y minus 2. It's a difference of squares. Over. What's y cubed times 2 over y squared? 2y. What's y cubed times 1 over y? Y squared. So take out a y. Come again? Sorry. Thank you, my brother. Thank you, thank you, thank you. So I take out a y from here, and I've got y plus 2y left over, correct? No, no, just y plus 2. Just y plus 2. So I've got y times y plus 2. Bye-bye, bye-bye. I got 2 times y minus 2 over y. Does anyone want me to do it method 1? I have time. Okay, thank you. Did everyone get this method? Okay. Method 1. What's the LCD of the numerator? Y to the third. So what do I need to multiply here, Papa? Okay, y squared. And to here? Nothing. So I got 2y squared minus 8 over y cubed, which equals 2 times y squared minus 4 over y cubed, which equals 2 times y plus 2, y minus 2 over y cubed. What's the LCD for this guy? The LCD for this guy, my brother, is y squared. Good. So what do I need to multiply here? A y. So I've got y plus 2 over y cubed. Stay, change, flip. Stay, change, flip. The y plus 2's cancel. The y to the cubes cancels. So I've got 2 times y minus y cubed is a denominator. It's y squared. Wait. No, y cubed is good there. Y squared down here. Sorry. Y squared down there. So 2x. Jeez. I'm so glad you asked me to do method 1. Y plus 2 times y minus 2 over y cubed times y squared over y plus 2. That cancels. Those two cancel. I got a y. So I've got 2 times, y minus 2 over y. Make sense? Make sense? Good boy. Okay, next. Okay. I'm not going to ask and then go back, so I'll just do it both ways for all of them. Yes, I'm going to have to, guys. I'm sorry. Method 1. I know method 2 is way better, but some people don't get it, and that's fine. LCD would be what for the numerator? X plus 2. So I don't need to multiply anything here, but here I need to multiply an x plus 2. So my numerator here is 1 plus x plus 2 over x plus 2, which is x plus 3 over x plus 2. Over, what's the LCD down here? It's not x plus 2. Oh, yeah, yes it is. That's a 1. It's x plus 2. So what do I multiply here? On x plus 2. And here, nothing. So I've got x squared plus 2x minus 3 over x plus 2. That factors out to be x plus 3 times x minus 1, beautiful, over x plus 2. Stay, change, flip. X plus 3 over x plus 2, stay, change, flip. X plus 2 over x plus 3 times x minus 1. Goodbye, goodbye, goodbye. I'm left with 1 over x minus 1. That's method 1. Long and arduous journey. Does that make sense? Thank you. Now, we got to do method 2. So I'm going to erase this. Method 2. What's the grand LCD here, boys? Yeah, the grand LCD in this case is x plus 2. So I'm literally going to multiply x plus 2 to every single term. When I multiply x plus 2 times 1 over x plus 2, what am I left with? 1. See you later. Then times x plus 2. So that's nice and easy. That's x plus 3. That's my numerator. Clean and simple. Now, what's x plus 2 times x? X squared plus 2x. You just saw something, didn't you? I saw that excited look in your face. You just clicked for it, didn't it? Super proud of you, bro. That's a good feeling. All right. Minus the x plus 2 is cancelable. Remember, I have this negative 3 that I got. So it's minus 3. So this comes out to be x plus 3 over x minus 1. And you're right. That's a lot harder. Tell me that method 2 isn't easier, guys. It's way easier. Now, again, I don't mind which way you do it. I will give you a little warning, though. If you do method 1 and that's your way and that's what you like and you don't even want to look at method 2, I respect it 100%. You better get real fast at it, though. I'm not going to give you 1,000 questions, but on a test or a quiz, you're not going to have time. The people that use method 2 are going to be done a lot quicker than the people that do method 1. So if you like method 1 and you just don't like method 2, I respect it. But I'm telling you right now, become great at it and fast. Okay? Last 2, my brothers. I would definitely use method 2 here, but I'm going to use both methods. I'm a man of my word. Method 1. What's the LCD for this guy?
3 times x plus 5.
Thank you, my brother. 3 times x plus 5. So what do I need to multiply here?
X plus 5.
And here. So this is going to give me x plus 5 plus 3, which equals x plus 8 over 3 times x plus 5. That's my numerator. And then luckily, look, this is already done. This is x plus 8 over 9. Stay, change, flip. Stay, change, flip. The x plus 8 and the x plus 8 cancel. The 3 and the 9. So I'm left with 3 over x plus 5. Okay? Let's show my brother. Thank you. You know what? In this instance, I don't know, man. I'm just so used to doing method 2. But yeah, that's a pretty quick way. That's why I said you can pick and choose. You'll get good enough so that you can say, no. This is going to be easier doing a method 1. Now let's do this method 2, though. Whoa, sorry. Let's clone it. Let's bring it over here. Let's bring this over there for a second. If I do method 2, what's my grand LCD? What did you guys say it was?
26.
Don't multiply it together. You're doing great, but you multiplied it together and makes it real tough then. If you it is 9 times x plus 5, but my boy said 9x plus 45. It's beautiful. He did nothing wrong. But could you imagine, bro, if you did 9x plus 45, it's real hard to figure out what I got to multiply to this, right? If you keep them as separate terms, though, my brother, it's a little bit easier, in my opinion. So 9 times x plus 5. When I multiply it here, what am I left with? Now you can go, it's 3 times x plus 5, which is 3x plus 15. And over here, what am I left with? 9. So this is 3x plus 24, which is 3 times x plus 8. Very good. Excellent. Over. What's left over here? The 9's cancel, right? So I got to multiply an x plus 5. So x times x is x squared. X times 5 is 5x plus 8x is 13x. And then 8 times 5 is 40. What times what is 40? But when added together is 13. X plus 5 and x plus 8. The x plus 8's cancel. I'm left with 3 over x plus 5. So you see that one's like it's 6 to 1, half dozen to the other. That one, both of them were pretty simple. But again, if you see it in your eyes, no, I like method 1 for those types for sure a lot better, go for it, brother. I'm not here to judge your method. I'm here to grade your work and make sure you do the procedures correctly. There are 2 procedures here. Do the one you like, my brother. And then last but not least, I got this guy right here. Let's go ahead and split this guy up. Okay, method 1. What's my LCD up here? XY. So what do I need to multiply here? A y. And here? An x. So I've got 2x plus y over xy. That's my numerator. What's the LCD here? XY. So what do I need to multiply here? A y. And here? An x. So it's 2x. No. 2y minus x over xy. Stay, change, flip. Stay, change, flip. Goodbye. I got 2x plus y over 2y minus x. Can I get rid of these 2's? No. Thank you. Good job. And last but not least, what's my grand LCD? See, things like this, for sure, I think method 2 destroys it. So it's xy. Good job, guys. So you're literally going to multiply xy to every single term. So what's xy times 1 over x? What's xy plus times 2 over y? What's xy times 2 over x? What's xy times 1 over y? Done. Done. Does that make sense, guys? Look, it's long problems. I get it. But you have what it takes. You can do this. And I believe in you. Thank you very much. Great lesson. God bless you all. Hope you learned a lot.